Okay, hello. Welcome to our 17th session of our Quickfire. My name is Moses. I can say I'm quite panting quite a bit because I just came back to office. Okay, we have been doing our pop-up events on our. Welcome to our 17th session of our Quickfire. Okay, so we are over the past few days we have been going around different Just Co outlets to do like pop-up events to just set up a small booth over there at the center just to say hi, and then also to increase our exposure in terms of like our company and our services to the working people that's around different Just Co outlets. Okay, so I just came back from Marina Square. Today is our fourth stop. We are already we have scheduled for this to be done 5 times. So today is the end of the fourth day. So tomorrow we will be doing it one more at the HQ, which is at Center Point. Okay, at HQ at Center Point. So over the past week, we were at Tampines at Asia Green. We were at McDonald House at Dhoby Ghaut. We were at Marina Square today at Marina Square. We are in the mall itself lah. Okay, and then we also what's the last one? Cross Street Exchange. It was formerly known as the China Square Central. So we went there yesterday. Okay, so each of them, I would say the different cultures and the vibes are very different from each of the co-working spaces. Some of them got more Caucasians, some of them got more like more Asians. But more or less, the whole co-working vibes has been more or less the same because everyone is just working around, and then we go in during the lunch hour between 12 to 2. Okay, so we wanted to in a way get a chance to interact with the crowd over there, and at the same time to interact with the people there. That is what we wanted to do lah. Okay, in the meantime, I'm also setting up my laptop as well to get my paper set up today. So same thing for those of you who are the first time entering our Quickfire. So basically, this session it's been done every week from Thursday from 5 to 8, and previously was live 5 to 7 okay, and now it's 5 to 7. So the main objective is for people to actually come in with their questions and they wanted to ask, and then what I will do is I will just straight away address their queries and questions over here. At the same time, I also want to run through some topical revision for the people who are watching. So right now I'm live on Zoom, on Facebook, and on YouTube as well. So whoever who wants to come in to interact with me, it's actually a free for all thing. It's not like a complimentary thing. Okay, so I don't want to make it like a too fixated format so that people can just come in to do revision on their own. Okay, I understand that now this week is the release of the WA2 results. Okay, previously we are talking about the weighted assessment, so on and so forth. So this week is the week where their results are released, the teachers are going through the papers. Okay, so how do you all fare for your WA? Do let me know. Okay, you all just passed or you all did well? Let me know. Okay, so of course there are some people who have scored well, there are some people who have not who didn't score that well. So nevertheless, I don't really put a lot of concern into all these results, because ultimately what's at the end of the day, the objective is for us to get a good grade at the end of the year, either for you to graduate or either for you to promote to the next year. Okay, so unless you're talking about this weighted assessments having a very big percentage, ultimately what we're looking at is the final, especially for the graduating students, the final paper, which is the O-levels, the N-levels, or the O-levels, N-levels, or the PSLE. That is what I want to focus more on. Okay. Okay, also let me also do it on my Facebook as well. Let me just quickly set it up over there. Okay, so in the meantime, what I'll be doing is I'll be just getting questions from the live stream, and then for people who want to ask questions to just come straight in to ask. That is what my objective of this quickfire to be. Okay, if you're looking for like fixated topics to go through, in the past I did pick up random topics to share online. Then only I realized that maybe there will be other tutors and other more established math tuition agencies or tuition centers who are doing it much better. And then they have done it more professionally in terms of the live stream, the equipment, the preparation, and all those. Okay, for me, I want to stay away from that area because I don't want to just create common competition out of nowhere. Okay, but I want to make it and to maintain it as a more freestyle basis for people who got questions and just come in. It's more like a live session for everyone to just come in. Okay, so I don't want to make the format too, too fixated, too fixated. Okay, so but nevertheless, when there are no other questions, or any queries or topical revision, what I will be doing is I will be going through some papers. That means mock papers from previous years and from other schools, and then we will just go through them. And then for those of you who manage to listen through, and then you all can take it as your own revision, or you can do it with me as I do the explanation and so on and so forth. Okay, so that's the objective. Okay, and also just a quick update about what's happening in the recent times. So me and my wife, we are preparing for this exam training program. For those of you who don't know, it's a preparation program for those people who are taking your PSLE and your O-levels this year. Okay, so what we are planning to conduct is like weekly time practice sessions, okay, for students who actually sign up, and then to really give themselves an opportunity to simulate an exam environment to take a mock paper. Okay, then after that, we will just go through the paper immediately, so you all can immediately spot your mistakes. And then from then on, you will know how to better revise, or you will know more specifically what are the topics that you need more help on, or more revision or more practice. Okay, so it's going to happen starting from the end of May, which is the last week of May. Okay, and then it will stretch all the way to the third week of June, where after that the school will be open, and then the students will go back. So it will be for the entirety of the June holiday. So for those of you who wants to sign up, okay, you all can reach out to me directly. For those of you who have already signed up, very good. So I will be looking forward to see you guys at the program itself. So the good thing about this program is that we have set up both offline and online options. So for those of you who really want to sit down and to have the proper exam setting, I will actually highly recommend for you guys to actually come over to my office here at International Plaza. Okay, that's the first option. The second option is for you all to do it online. That means with the invigilation of Zoom, I will do it. That means the going through the sessions itself will also be done on Zoom as well. It will be done on Zoom. So it's to me, both options are available. But if you really want to have the best experience, best for you all is to come down to the center, and then we'll really sit down and do the paper on the spot, because it's more about the simulated experience. Okay, as tutors, we are going through the guided instruction and the revision every single week to help you in certain questions. You got all the time to think, you got all the time to practice for that specific type of questions, or maybe just that one question itself. Okay, but however, are we prepared? Okay, are you prepared to actually simulate that kind of success, the same correctness of answers, or the same way of thinking in terms of the problem solving in the exam environment, alongside with all your other topics and other concepts that you are being tested on. Okay, so is the exam, that's why we always, because the school right now has also been cutting down less and less emphasis on mid-year exam papers, mid-year examinations. Okay, so they're kind of like taking WA2 at like a mid-year. It's like a mid-year. It's still the same thing, they're still testing the same content, but they just want to call it WA2 because they want to so-called reduce the stress of students or parents looking at it as a mid-year big exam. Okay, but in fact, when they change the format from a mid-year exam or our very well-known CA1, SA1, CA2, SA2, when they changed the format, the content didn't really change much. So it's just changing. I feel that it's just a changing of packaging to kind of mask the stress away. But essentially, it's still the same thing. Okay, what do you guys think about it? Okay, let me know. Okay, in the meantime, also let me just fetch up my papers and to see what do we have to install for this week. Okay, this week I actually wanted to up the challenge. Last week we did a Sec2 paper 1. Okay, a Sec2 paper 1 paper. So it's actually pretty easy. And then for most of you, you guys are able to do some revision. But today I want to go a bit more difficult. I want to actually go into AMAX. Sec4 AMAX. That means it's on the highest of levels. Okay. I want to find a paper that I haven't done yet because all the papers I have over here, about 10 plus schools, I've already attended like all of them. Okay, let me try to find an empty paper. Okay. If not, you guys will just see my answers. A bit no point. Okay. Okay, this one done. Bendemeer has been done. How about Ang Mo Kio? Okay, this is Sec4 EMAX. Okay, EMAX has been done as well. Okay, or maybe you all have any suggestions. If you have any suggestions on what paper for me to go and try, or maybe you all have done it yourself and you realize that hey, actually this one is quite difficult. Okay, or maybe it's worth a challenge. Let me know. Okay, what paper should I try? Otherwise, I see that most of my papers are done, unless I go and download new papers online. Sec4 paper. Okay, I have a Sec4 AMAX free test paper. Oh, these are from 2020. Okay. Okay, Ken. This is actually, okay, I found a paper already. Okay, so this is actually a mock paper that is provided by a home tuition agency called MindFlex. Okay. Quick shout out for them. They are a tuition agency that match tutors to students. Okay. I'm not doing an endorsement or anything. Just a quick shout out that I'm getting a paper from there. So if you want to find this paper, you can actually go to their website, MindFlex Home Tuition, and then you can download the mock paper. So this mock paper is being set up by them and it's being uploaded by them for students to go and try. So in their perspective is if you can do, good for you lah. If you cannot do, it's time for you to find a tutor with us, which is the agency. Okay. So today, let's try and challenge ourselves to get this paper done. Okay. It's a Sec4 AMAX 2020 paper. Paper 1, is it? Is it paper 1? Paper 1, yes. So it's about 2 hours. Let's see what we can do in 1.5. Okay. And let's see if you are able to score. Of course, if there are any errors that you all have saw that I did, okay, I'm not perfect. I'm not 100% perfect. If you guys see any mistakes, let me know. Okay. Okay. So let me just quickly share my screen and we are good to go. Only the host can share. Oops. Hang on. Okay, whoever is online, do say hi. Okay. Otherwise, it's quite lonely up here. Yeah, but anyway, I'll also be taking this chance to record my own content. So in the future, I can do some editing and then to take out some separate individual questions. So it can be done as like small snippet sharing. Okay, that is my plan. That's why even if there are people watching, if there's no one watching, even there's people asking or no one asking, I don't really care because I'm still going to film my own content. So you can take it as I'm just talking to myself. But to me, I feel that this content in the long run will still be beneficial. Okay, so I think the content is up already. Okay, I can share screen already. Awesome. Let's see if the screen is up. Okay. Okay, all is good, all is good, all is good. I see that all my things are up. Okay, let's go back to the paper. Okay, just to ensure that you guys can see the paper. Okay, with that, let's get started. Okay, so question 1, given that theta is obtuse, tangent theta is alpha. Expressed in terms of alpha, cosine theta, 3 marks. Just like that, 3 marks. These are the kind of questions that will always appear and then will make people go mad because they don't even know what's going on. Okay, so in this short one line, there's actually a couple of clues that we can do also. Okay, number 1, theta is obtuse. Okay, can I write? Yes, theta is obtuse. Without the owner's password, you do have the permission to save this document. Enter the owner's password to unlock saving. Don't say that, never mind. But really, oh no, wait. Oh, is this the reason why I cannot do this paper? Interesting. I don't know if I can see if I can import it somewhere else so I can do it there. Okay. Let's try. I use my exam app to do it. Okay, but anyway, just a quick shout out. What is this app that I'm showing on the screen? It's actually my exam app. So basically, I take down all the different papers that is being done by my students, and then I will actually upload it here. So when I upload it here, they will be able to, I can actually erase all the, there it is. You can erase all the markings and the writings of my students, and then it will print out a new paper. That's very awesome. It's a very awesome tool. Okay, but they got the copywriting there, but I don't really care. Okay, let me just do some quick adjustments over here and to let you see how it works. Okay, so basically I have a new paper here. It doesn't matter. The papers are all here. Oh, it's quite a lot of things. Okay, let me just quickly do some edits. 旋转, yeah. Even the paper 2 is here. So maybe next week I can do paper 2 lah. Okay. Question 6, question 7, question 8, question 9, question 10 with some graphs. Okay. Question 23, and we are done. The answer key is at the back. Okay, awesome. Let's save this. Hopefully, if I can save the paper, then I'll be able to do the paper lah. Okay. Or maybe you guys have already done the paper before. Okay, so while it's processing, hopefully it works. Okay, just also a quick update about what's going on right now. So apart from the exam training program that I'm doing, we are also going to do courses. Okay, we are going to establish some courses to be shared online as well. Okay, so right now I'm still in the creation of my first online, it's like a digital online max course to be up on online course platform. Okay, so that means people will just make the purchase and watch the courses and access to the materials there. So who knows, if all works out, so next time I'll be able to publish more courses over there as well. And at the same time, the good thing about that platform is able to let me upload digital downloads. So for example, next time I want to do like study notes, then you can upload there also. And then people can also access it either for free or maybe for a small I don't know, payment or something. Okay. So at the same time, the math database is still ongoing, just that I didn't really manage to constantly upload it as often as the past, because right now there's a lot of things going on, the exam training program, the online course, and then all the printing and all the admin stuff is there's quite a lot of things to handle, we have to admit. So and as also while preparing for this exam training program, we have to adjust and to reschedule all of our June assignments. That means our current teacher assignments, we need to also change all the timing to mornings, because we are going to do the exam training program in the afternoon. Okay. So really, there's a lot of admin to be done. There's a lot of crazy stuff, crazy stuff to handle. So pardon me on this one. Okay. Hey, I think it's done. So let me just quickly. Okay, hopefully it will be out. Wow, so big 103 MB Why so big? Hopefully it will work. PDF Okay, nevertheless, I just going to like try. Anyway, it's just for today. Sec 4 Math 2020 paper. Okay, can. Let's go back to this paper and see if you are able to have it. It's over here at the bottom. Hopefully I can see it. Really, hopefully I can see it. It's quite a big document. It's a very big document over here. Hopefully it will work. Wait. Now can I write or not? Okay. Can I write? Yes, I can write. Awesome. Okay, awesome. Let's start. Let's start officially now. It's like 15 minutes into it. Okay, so let's start. Okay, given that theta is obtuse, tangent theta is alpha. Okay, so expressed in terms of A, what is cosine theta? Okay, number one is obtuse angle. Obtuse angle means it's more than 180 degrees. Let's just put it as such. Okay, of course, when it is already given to us that is theta and it's obtuse, we need to observe what is the relationship between a tangent theta and a tangent of the complementary angle. No, supplementary, sorry. So for example, I press that because last time when I shared about this, the most efficient way and the most straightforward way is to test values. Okay, I don't want to spend time to memorize special values and all that stuff. The best way is to just test for values. Okay, so you see that I have seen from my calculator that if tangent theta is alpha, so the subtangent of this supplementary angle is negative because I can just straight away test like that. Okay, so tangent 60 is about this 1.73, and then I press whatever that's next one, which is the supplementary angle, which is negative of the value. Okay, so one thing to take note, this angle, which is 180 minus will be how many? Will also be so now cosine. Okay, okay, let's see how we can do it. Tangent theta is alpha. So if you were to say alpha, what is alpha? Because tangent theta, tangent is what? Tangent is the opposite over adjacent. Opposite over adjacent is where the perpendicular lines meet lah. Okay. This is quite a bit messier. Tangent theta opt-in of it. Tangent theta is alpha. That. Okay. So tangent theta is alpha. Same thing, I will also want to draw that same line. This is just a sketch like that. So theta looks like that. Okay. And of course, if I were to map it along the quadrant, it will be, oops, it will be along here. Okay, tangent theta is alpha, but they told me that theta is obtuse angle. So this angle over here will be 180 minus theta, and then this will be theta itself. Okay. So one thing to take note though, because they already say that tangent theta is alpha, and we can also conveniently say it's alpha over 1. That means the opposite of this angle, O over A, is actually alpha to 1. Okay, so how do we actually represent it in the diagram so that we can use that thing to actually help us find something else? Okay. Okay, and since the question is asking for cosine theta, we also need to understand that cosine theta is also equals to the negative of the cosine of 180 minus theta. Okay, same thing. How can we understand this? Is also through the use of the testing of values. Like I said, I don't really need to go and memorize the values because it's a waste of time. Just need to see it like that as it is. Okay, so can I say that if, for example, I want to change the focus from theta to 180 minus theta, and it already say that tangent theta is alpha. So can I say that the tangent of 180 minus theta is minus alpha? Okay, this is quite minus alpha. So for minus alpha, how does it work? Minus alpha, how does it work? Okay. So let me just redraw this one. What is happening is over here. Okay. So this is theta. This is 180 minus theta. I try my best to draw it as clearly as I can now. Okay. Can you all see it? You also need to check whether my stream is working as well. If not, okay, yes, it's working. Okay, 180 minus theta. And then so that it means that this is actually minus alpha over 1. Okay, so how do you know this one? So that means if I was zooming here, this is alpha, also called minus alpha, and then this one. Oh shit. I keep missing out the values here. 1. Okay, minus alpha, this value of minus alpha, this one. Okay, I know it's supposed to be minus alpha, then it means the value should be at the bottom lah. Okay, but like I said, it doesn't really matter. It doesn't really matter because in this case, tangent is a negative in this case. So you can just take the value as it is, because now as they say cosine, right? I need to go and find what is the hypotenuse of this triangle. So how to find the hypotenuse of this triangle is just simply using the Pythagoras theorem. That's why it's worth 3 marks lah. It's quite a lot of things to do. Okay, so the hypotenuse is equals to 1 square plus alpha square and the whole thing square root. Okay, so this is the hypotenuse itself. So if I want to find cosine, so if I will say cosine of 180 minus theta is equals to 1 over square root of 1 square plus theta square. I can say 1 plus theta square lah. And therefore, it leads us to our final answer, which is cosine theta is equals to negative of this value, which is theta square plus 1. Just like that. Okay, so this will be the answer. Okay, next one. Cosecant theta. Actually, just now I just wiped out the watermark in the video because it allows me to remove the handwriting, but I didn't have time to do so. But it's okay. Let's see how I integrate it from here then. Okay, can. Cosecant theta. Let's understand what's cosecant theta first. Cosecant theta is just essentially 1 over sine theta. Okay, and we must understand that sine theta is actually equals to the sine of 180 minus theta. So technically, I just need to go and find what is sine of that theta of 180 minus theta, which is the sine of this one. Okay, to find the sine of that one of this angle, okay, I just need to take the sine, which is minus alpha over. Okay, let me just write again. So sine of 180 minus theta is equals to minus alpha over the hypotenuse, which is what we have found out earlier on, which is here. Okay, and now I want to find the reciprocal of it. Okay, I want to find the reciprocal because it's looking for cosecant, right? Okay, so 1 over sine 180 minus theta will be the minus square root of alpha square plus 1 over alpha. This will be my answer. Okay, so that will be my answer for question part 2. too low FPS. Never mind lah. Can work can already lah. Okay, quite straightforward on this one. Okay, let's move on. Okay, question 2. Find the set of values of the constant k for which the curve y equal to minus x squared plus 1 minus k x minus 2 lies entirely below the line x plus y equals to 0. Okay, a mouthful over there, even though it's only 2 lines, but there's still a lot of work to do. Okay, when we see lie entirely below the line, lie entirely above the line, the only thing that we need to think of is b squared minus 4ac. We are talking about the nature of roots over here, nature of roots. Okay, so for those of you who forgot what is the nature of roots, this is a good chance for you to do some revision. Okay, so for this one, how do we handle this? Okay, we've got a whole bunch of equations over there, and I want to put these two equations together. Okay, that means y equals to minus x squared plus 1 minus k x minus 2. This is my first equation. Then the second equation will be x plus y equals to 0. That's my second equation. So essentially what I need to do is I want to put these two equations, I want to equate them together and go and find the value of b squared minus 4ac. That is what we are looking at. So from 2, I can make y the subject of formula, which is y equals to minus x. Okay, and then I'll sub this equation into my first equation. So sub equation 3 into equation 1. Okay, so minus x equals to minus x squared plus 1 minus k x minus 2. So if I were to do some manipulation to throw the things around, I'll get x squared minus x minus 1 minus k x minus 2. Okay, I hope you all can see. Just ignore the watermark. Just don't care. Let's continue first. Okay. Okay. So let's continue. So this one is equal to 0. Okay. Like I have mentioned quite a lot of times, how do I ensure that my equation at the end of the day is a nice one? I want to ensure my x squared term is positive. Even though right now the x squared term is on the right hand side. Okay, and it's easier to shift my minus x over from left to right. But I want to do it the other way around because I want to make my x squared a very nice one. Okay, so from here, how can we do it? Continue as an x squared. Then I see I can take out x as a common factor over there. So I take out x as a common factor. I have 1 minus 1 plus k. Okay, hang on. This is actually quite a lot of things. Okay, of course, on the safer side, instead of taking out x as a common factor like what I did, okay, I scared that I will make mistakes somewhere over there. What I'll do is I'll go expand my numbers, okay, to make sure that I'm working on correct things. Okay, so x squared minus x. Then I expand this one first, which will be minus x minus kx minus 2 equals 0. Okay, and then I go and expand it out. Okay, this will ensure that no matter what I do, it will still be correct. Okay, just to ensure that I don't do any stupid, silly mistakes. Minus x plus kx minus 2 equals 0. Okay, so this one looks decent already. Now I can afford to put them together. Okay, so x squared minus 2x plus kx minus 2 equals 0. I can continue. X squared minus x, that leaves me with 2 minus k. So this ensures that my coefficient for b, the bx in the b, the middle constant, the middle coefficient is correct. Okay, I just spent another few more lines to do so lah. This is just for fail safe. Okay, just to be a fail safe. So from here, it's quite obvious already what is my a, b, and c. So from here, I want to find my b squared minus 4ac. Okay, and they say lies entirely below the line. When they say lies entirely below the line, it means what? That means it does not touch the line at all. That means it must be less than 0. That means there's no intersection point. When there's no intersection point, means the discriminant must be less than 0. So in this case, I want it to be less than 0. So b square minus 4ac, let's go ahead and to find this out. Okay, what is my b square? My b square is actually minus 2 minus k square. Okay, very important also to put in the minus sign in front. This ensure that our answers will be correct. So 4ac must be less than 0. Okay, then from here we can go ahead and to find out what we are looking for. So this is actually k minus 2 square lah. Okay, so let me just quickly do this one. So it's a k minus 2 square. So it's k minus 4k plus 4. Okay, plus 8 less than 0. Okay, from here we can continue. K square minus 4k plus 12. Okay, equal 0. Okay, so from here we can just straight away key to our calculator and get an answer for ourselves. Okay, let's have a look. If my answer go wrong somewhere because I got imaginary roots, that means what? No real root. Okay. Okay. Let's have a look at our previous working. X square. Y equals to minus x. Fair enough. I suspect it's the x manipulation there that got me off a bit. Okay. Okay. Let's rearrange our workings a bit so that another plan that we can ensure that our workings are correct is to just shift the minus x over from the left hand side to right hand side, and then I change the sign throughout. You see, I'm always not very comfortable with working with minus x square. Okay, so in this case, let's just bring it over first. Okay, minus x minus kx minus 2 plus x equals 0. Okay, then at this point, I want to group in all my stuff first. Okay, x squared minus x, this is plus kx. Okay, plus 2 minus x equals 0. Okay, so from here it will be x squared minus 2x plus kx plus 2 equals 0. I seem to be getting the same value. So this is 2 minus k plus 2 equals 0. Oh, plus 2, huh? Is it a plus 2? Looks like it. Plus 2, plus 2, plus 2. Okay, yes. So from here, x squared minus 2 minus kx, okay, plus 2 equals 0. So what's the mistake here? Okay, if I were to just change my values a bit, it will be minus 8. So minus 8 will give me a minus 4. Okay, I managed to get some values, but the value is not very nice. Doesn't look very amazing. It's like tons of decimals, but it is still a value. Okay, so for it to be b squared minus 4ac, it's less than 0. I want it to be less than 0. After I solve my calculator, I got these two values. Okay, it will look like that. This is negative 0.828. This is 4.828. So they say less than 0. When they say less than 0, they want it to be below the curve. So this will be my values of x. 0.828 x. Okay, I cannot touch the values, right? Okay, so 4.828. So that's my answer. Okay. Let me just quickly go and see whether my answer correct or not. If not, then malu. Okay, so they have a 2 minus 2 root 2. 2 minus 2 root 2. So this one is, I believe, should be the value that is after you do the quadratic formula. Okay, 2 minus 2 root 2. 2 minus 2 root 2. Yes, correct. So in order to show it to you guys, this is what we'll get. You can see it from here. Yeah, this is 2 minus 2 root 2. And the answer is minus 0.828. So this is in line with the the answer that we got from here. Okay, so I'll just go ahead with this value then. Okay, can. Good, let's go on. Okay, given that y equal to h e to the power x plus k over e to the power 2x, and that d square y minus over dx square minus 2 dy over dx equals to ex plus 2e minus 2x. Find the value of each of the constants h and k, 4 marks. Oh, this is damn tiring. This is very tiring. But nevertheless, this is on the fact that you guys have already learned and to master your differentiation of natural logarithms. Okay, so since we already have the y, we can go ahead to find our dy dx and our d square y dx square. That means it's the first derivative and the second derivative. Okay, that is quite a lot of things to do. So I see I can write smaller. I see I can write smaller. Okay, y equal to h e plus. Okay, let me just bring it down. So from here, how do we find our dy dx? Okay, from dy dx, I just need to integrate my terms individually. So hex, okay, hex will just be ex differentiate already, you still get ex. So hex, you differentiate already, you still get hex. No difference. No difference. Okay. So continue on. And I want to differentiate k over e to the power 2x. So when I differentiate k to the power e to the power 2x, right? So I want to okay, so I were to take it out. I take out the k as a constant. When I differentiate my e to the power 2x, right? It will be 2e 2x. Okay, so it will be k over 2e 2x. Okay, let me see again. Ensure that is correct. Minus 2. No, minus 2. We got ourselves almost tricked there. Okay, very important because this one, I just do an extra footnote to remind you guys what is this. We have a k over e 2x. Okay, I just do a small note here. This is actually, if I were to rewrite everything to the numerator, it will be k e to the power of minus 2x. We need to understand this. We need to establish understanding first. So when we were to differentiate this one, right, it will be minus 2 k e minus 2x. Like that. Yes. Okay. So let's bring it back down here. It will be minus 2k over e to the power of 2x. Like that. Okay, so this is my dy dx. Okay, let's just quickly polish this up by putting the sign to combine to what's in front. Like that. So this is my dy dx. So my 2 dy dx will be twice of this thing. Okay, so 2 times dy dx will be 2hex. Okay, now it's getting more and more letters, right? There's no numbers anymore. Okay, over 4k e to the power of 2x. This is my dy dx. Okay, keep it as such first. Okay. Let's continue. I also need to find the second derivative, which is the d square y dx square. So let's do it over here, so we can better compare. Okay, same thing. D square y dx square, right, is just taking dy dx and differentiating again. Okay, don't get too freaked out over this. Okay, so hex, if I want to differentiate again, I'll still get hex. But this time, I got minus 2k over e to the power of 2x. Using the same logic earlier on, if I were to differentiate e minus 2x, I'll get minus 2e minus 2x. So the e to the power of 2x, right, still will be the same thing. However, there will be another minus 2 that is being produced. That leads me to 4k e 2x. Okay, can anyone get this? Okay, so now moving on, let's piece the things together and then we see how can we match it to what we are looking for in the question. Now, d square y dx square minus 2 dy dx equals to ex plus 2e minus 2x. So I want to equate everything together very nicely. So dxy, d square y plus dx square minus 2 dy dx is equals to hex plus 4ke to the power of 2x minus what? Minus this one. 2hex minus 4k over e to x. Like that. Okay, let's simplify the terms. So we put them properly, then we go and compare. Okay, so I got hex and 2hex. When I put them together, I'll have this one is minus, so it's actually minus hex. Okay, then I got a 4k over e 2x plus 4k to the power e 2x. So it's actually 2 times of the same thing. If I have 2 times of the same thing, I'll get 8k over e 2x. Okay, very interesting value over here. And then now, according to the question, what is being given is actually equals to ex, okay, plus 2e to x plus 2e minus 2x, 2e to the power 2x. So in a way, in the question, right, they already put the e to the power 2x back to the numerator form. You must understand that, bring back to normal form. So what we are doing here, right, essentially, we are only comparing the coefficients. So we can just say by comparing coefficients, okay, minus h is just equal to 1. H equals to minus 1. Okay, and then what we have over here, 8k is equals to 2. So k is 1/4. So k is 1/4, h is -1. Let's check our answer. Yay, we got it. Very good. Question 3. Okay, can. H equals -1 and k is 1/4. That's a lot of stuff actually. But it's not that bad lah. It's really not that bad. Okay, so we need to ensure that we got the final answer, and before we go and verify that, hey, actually our differentiation is correct. Okay. So when you present the model, when you present your working, you can present it as just like what I've presented here. It's okay. It's okay because as long as all the critical steps are being shown and then you know how to put them together, we are good to go. Okay. Yay, awesome. Let's go on. Okay, a cylindrical ice block of radius RCM is melting in such a way that the total surface area A is decreasing at a constant rate of 72 cm squared per second. Given that the height is twice the radius, and assuming that the ice block retains its shape, calculate the rate of change of R when R is 5. Okay, same thing. The thing about AMAX is always they like to put in a lot of word information, make you go confused. So the first thing, right, is always to understand the question and what is being given to us. Okay, so they told us that the base radius is R. The shape is in the form of a cylinder. Cylinder is like a cylinder, looks like that. So we must understand what is being given to us. Okay, so let's write, and then we also need to convert the information that is being given in the question to mathematical notations so that you can put it into our calculations later on. Okay, so what is given over here? The total surface area A, let's highlight. The total surface area A is decreasing at the rate of 72 cm square per second. Okay, how do we write this? Okay, so if I will zoom in, that means dA over dR equals to minus 72. No, sorry, dA over dt. Because what they are comparing the rate, right, with respect to time. That's very important. They say at a constant rate of 72 cm squared per second. The best way to look at it is to look at it in terms of per watt per second. So that means they are measuring it with the time. Okay, so it's dA over dt. Okay, and then also given us that the height is twice of radius. Okay, so the h is equals to 2r. That is the second information. So what are we finding? calculate the rate of change of R. Okay, when they say rate of change means what? Also over dt. It means I'm looking in respect to time. With respect to time, very important. So find dr over dt when r equals to 5. Okay, very straightforward, like that. Okay, so from here, we got all the information. Now we have summarized all the information from the words to these 3 pointers. D over dt is minus 72. H is 2r. Find dr dt when r is 5. Okay, we need to lay out everything first. So next up, how do we start writing our working? Okay, my recommendation, like I said, is my recommendation is to lay out the plan first. Like I tell all my primary school students, my secondary school students, is always to lay out your plan. When you write down the plan in terms of the formula, you'll know exactly what are the components that you need to find. Okay, so now the question is asking me for dr dt. Okay, so I need to go and find how to find dr dt. So straight away, since the question asked me to find dr dt, so don't confuse yourself. Write down dr dt first. What is dr dt equates to? Okay, is equal to dr over dA times dA over dt. Okay, so how do I derive this straight up from here? Okay, it is through the cancellation of fractions. Okay, I know that this fraction thing is not very accurate to be used over here, but actually you can just borrow the idea of doing rate of change because it's a rate of change question. So in a way, what am I wanting it to do is to do this. Okay, so now this is to use the idea, but anyway, we have already understood that dA over dt is negative 72. So let's write it down here first. So it's dr over dA times negative 72. This is what I want to find. But anyway, dA over dt has already been given to us. So now you see, now the focus we need to look at is dr over dA. And what is dr over dA? We cannot do that, but we can only do a dA over dr, because when we find dA over dr, after that, once we found the expression or we found the value, then we do a reciprocal of the value. Then we will get the answer. Okay? Yeah, let me just tune my screen a bit. Okay, my screen is working, but it's not displaying. So weird. Okay, shall I just continue? Because it's still showing on my broadcasting software. Never mind, I continue first. Come on, just like 跟我配合一下好吗？ You just black out leh. You don't like that leh. Okay, never mind. I continue first. So we want to find dA over dr. That means what? I need to differentiate the formula of the area, surface area, to with respect to r. Okay, important. I want to find. So that means the objective is to find dA over dr. So we need to, in order to find dA over dr, I need to know what is A in terms of r. Okay, that is where I need to bring back to use the formula of the cylinder. Then I convert everything to r. Then I do a differentiation. Okay, we need to understand this one first. So we need to understand what is A. And A in our question is being given as the surface area, total surface area A. So if we imagine a uniform cylinder, how will it look like? That means it will be 2 pi r squared, that represents the top and the bottom, together with 2 pi r h. That means 2 pi h is the curved thing, it's the curved surface. Okay, and then, but you see that there's a h here. There's a h here because this h, I want it to be in terms of A and R only. I don't want h. But can I remove the h? I cannot just take it out, right? Okay, but you see, in the question, there's already given to us that h equals to 2r. So I need to rewrite my h in terms of 2r. Okay, and I simplify everything. I'll get 4 pi r squared. And then if I was to see, there's a 2 pi r squared, there's a 4 pi r squared. What can I do? I can group like terms, which gives me 6 pi r squared. Okay, important. So now from here, can I go and simplify? Yes, I can. Because 6 is a constant, pi is the constant, r squared is the one I'm looking at. So if I were to do a dA over dr, it will just be equals to 12 pi r. That's it. That's my 12 pi r. And at the same time, can I go and find the value of this dA over dr? I can, because they asked me to find my dr over dt when r is 5. Okay, my r is 5. So I can just continue my working here. When r equals to 5, my dA over dr is equals to 60 pi. Okay, 60 pi. But the thing is, I don't want dA dr. I want dr dA. So I need to do a reciprocal of this thing, which is 1 over 60 pi. Okay, so now I got my value of dr over dA already. Can I bring it back to my original place, which is here? Because you see, this is my plan. I want to find my plan. In order, if I can find dr over dA, I can find what I want already. Okay, so I will just bring it up here and to help us bring it back to the equation again. So dr over dt equals to dr over dA times negative 72. Okay, and then I will want to put in my 1 over 60 pi times negative 72. Okay, so from here, it's a very simple simplification process over here. Divide by 12, divide by 12. This is 6, and this is 5. Therefore, my answer will be 6 over 5 pi. And also dr dt, you need to put in the unit itself, because r is a linear unit, so it's cm. T is a time per second. So this will be my answer. Minus 6 over 5 pi cm per second. Okay, very straightforward working. 4 marks, quite straightforward actually. The thing about A max is that if you have a 4-mark question, it is not requiring you to think a bit out of the box. It's just following the standard protocol of questions answering. Just follow through can already. That's 4 marks. If they ask you about 5, 6 marks, okay, maybe something else had to be done. But 4 marks is kind of straightforward. So that is all to it. Okay, so here's the full working. Have a look. So take some time, digest this. Then we can move on to the next question. I see if I can fix my screen here to help me show up my. If not, I'll be just facing a black screen throughout. Alamak, this is bad. This is bad. It's working, but it's not showing it. I think the problem is my HDMI cable. Let's try again. Let's try again. Hopefully it works now. Please give me my screen back. Give me my screen. Yes, it's back. Yes, awesome. Okay, let's come back here. Okay, so I also want to take this chance to go and label down all my steps to make it more clever for you guys. Okay, find dA dr. So after I find dA dr, my step 2 will be find dr dA by doing a reciprocal of it. Then step 3, sub value of dr dA into dr dt. 是这样 ，OK， sweet。 Okay, can. And hopefully my live stream is working. Should be working. Is that where it is? Should be working fine, I guess. Yes, good. Okay, have to take a bit more attention into the streaming wise because sometimes I don't know whether it will lag and then I don't know how much of the stream has been lost. Okay, so I'm actually trying to constantly see whether my streams are running well or not. Okay, let's go to the next question. Okay, Miss Lee bought her dream car last year. Question 5. Okay, the value A of the car is given by the formula A equal to 150,000 e to the power of minus pt. Okay, where P is constant, T is the age of the car in months. The value of the car after 2 years is expected to be 120k. Find the amount of which Miss Lee paid for the car. and determine the value of the car after 40 months. Give your answer in US dollar and find the age of the car when value drop to 60,000. Give your answer to the nearest month. Okay, the weight. Okay, this is actually super easy because it's also just testing you on the nature of natural logarithms. That means your ln. And this is a very typical classic example of a declining ln graph, because we are talking about the depreciation of cars. For those of you who drive cars or we are into cars, you guys will know that it is actually when you first bought it, it is of a fresh value. The moment you drive the car, you got the car and you drive it out of the garage or the sales house, the value will start to drop already because of the engine wear and tear, so on and so forth. Okay, so the value of the car will just depreciate. That's why we call it a depreciation value. Okay, so depreciation rate of how maybe a certain fixed percent per month or per year. Okay, so this is a very common example. So of course, when it comes to such questions, I highly recommend everyone to go and look around you and think of it like a real life situation, because all of these numbers, all of these situations, right, are just happening all around us. We will be getting a car in the future now anyway, so it's good to have a basic sensing of what we expecting when we were to really go and buy a car. Okay, let's come back to this question. A is 150,000, E the power of minus PT. So find the amount of misly paid for the car. You see, when misly paid for the car means what? The T is 0. Okay, the T is 0. Okay, don't think too much. Because when they say they just first paid for a car means what? T equal 0. So A equals to 150,000. Okay, E minus E to the power of 0. So it is just 150,000. Okay, guys, don't think too much. It's only 1 mark. So A is 150,000. That means the original price in which Miss Lee paid for the car is 150K. Okay, that's all it means. Okay, don't get too like whoa. Okay. Okay, question 2. Part 2. Find the value of car after 40 months. Give your answer the nearest dollar. So now the most straightforward strategy is to find P. Find the value of P, because we don't know what that P, the value of the P determines how fast your car depreciates. Okay, so you need to find P. And they've already given us a scenario. The value of the car after 2 years is expected to be 120,000. So all we need to do is to do a comparison. So 120,000 is equals to 150,000 E minus P. Now, what's the value of P? Very important now. You look at the value. T is the age of the car in months. And after 2 years, it's expected to be 120,000. Means what? T is how many? If you say T is 2, I'll whack your head. Okay? Okay, just kidding. Okay, T, because T is in months, they are saying 2 years. So I need to convert years into months, which is 24. Okay? Small trick over there. Don't fall into it. Okay, so it's actually 150,000 E minus 24P. Okay, so from there, can we actually go and solve for the value of P already? It's actually very straightforward. Okay, I just take 120,000. In fact, I can just say 12 over 15. Anyway, it's the same thing. E minus 24P. Okay, so therefore, from here, we can straight away find the value of P already. So minus 24P equals to ln of 12 over 15. Okay, so we can go ahead and find this answer already. Okay, just need to type in ln, then 12 divided by 15. Okay, you get minus 0.223. Okay, and from here, I just directly solve for P. Okay, cut the long story short. So P will be 0.00929767. Okay. And I can just leave the answer, I can just leave the solution as it is now, because I'm not in the final question, they are not asking for the value of P. They are looking for another value in P in like 40 months or something. Okay, so I can leave it as a working value. I want to retain the most highest level of accuracy. Okay, so using this value of P, let's bring it back in and find the value of A after 40 months. Okay, so it's 150,000 E. Then I bring the P here. So it's 0.00929767. Then how many months? 40 months. Okay, it's okay for you to write everything here. It's okay. Okay. In fact, I do recommend that you write it like that because it's much more accurate. Okay, but the thing is that how do you retain this value in your calculator? This one, important skill, okay, especially for A-Math students, is to use the memory recall and store function. The store and the recall function. Okay, if you don't know how to store and recall values, you are going to be in big trouble for A-Math because you want to retain the working values and the exact values in your exams. Okay, so from here, I want to store this value of P. So I got this answer, right? So I can press store. I press store, right? And then I choose one of the letters to put the value in. So in this case, I want it to be A. So you see in my indication, it will say answer is pointing to A. That means next time if I will recall the value of A, it will be this value of P. 0.009297 whatever. Okay. Important skill. Okay. So I'm going to bring it back, you guys. So I key in the calculator 150,000 times E to the power of negative, recall A, then 40A. Like that. So as you can see on my calculator, you see instead of 40 times 0.00929767, it will be 40A because as long as I stored my value in the variable A. Okay, so when I press the answer will be minus 40A. Why got syntax error one? Okay, minus 40, recall A. E of minus, recall A times 40. Is it because I didn't put the multiply sign over there? Okay, so 150,000 times this value will be 103,412,865.1. Okay, this will be my value. Okay, when they say nearest dollar, okay, 103,413 to the nearest dollar. Okay, quite straightforward. Okay, and most classic, another question, find the age of the car when its value dropped to 60,000. Give your answer to the nearest month. That means you want to find the value of T when you have given a certain value of A. Okay, so 60,000. And then you say go what? Go drops to 60,000. Okay, so 60,000 equals to 150,000 E minus value of P, which is 0.00929767 times T. Okay, just like that. And then same thing, I will want to solve for the value of T in this case, which is minus yeah, just like that. Okay, and once again, I can also do the same operation to go and find the value of T in this case. It doesn't matter. 6/15. Okay, and then I divide it by, now I want to divide it by the value of P because now because when I do ln of 6/15, I get minus 0.9162 blah 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 blah. So I want to take this value and divide it by the value of T to give me my T. So same thing, you see, that is the reason why I want to do a recalling of values. Okay, so when I divide, I recall A. Okay, I'll get 98 months. 98.5508 months. Okay, when they say nearest month, okay, 99 months then. Nearest month. 99 months. 99 months is about, it's actually not a lot though. 6 years is 72, about 8 years. 8 years. 8 years and 3 months. Okay, about there. 60K. Not about 60K. Okay. About there, 60K. About 8 years. About there, 8 years and 3 months. Okay. So of course, you see, when we do all this like self-thinking, it actually have to make sure that our answers make sense. Okay, don't this answer cannot be like 14 months. 1/4. Can the answer be 1/4? 14 months? Cannot be. 14 months is only like what? 1 year plus? How can your car depreciate so much within 1 year? Doesn't make sense, right? Okay, so every time when we solve for a question, you must ensure that the answer makes sense. Okay, otherwise you know that it's time for you to redo the question again. Okay, so in fact, I'm very confident that this answer will be my correct answer, and I don't need to, at the end of the whole paper, come back and check again. Don't need. Okay, I check it right here, right now. Okay, good. Let's move on. Factorize 2x cubed 3x squared minus 8x minus 12. 3 marks. This one. How? Any ideas? Okay, so for here, when they just have these two, they have only one word, one instruction, and one expression. The first thing I will do is to take out my calculator and play cheat. Okay, let me tell you guys, it is okay to do so. Okay, at least you know that what is the value of the roots, and then you know how to work it out from there. Okay, so immediately when you got this, right, calculator time. Anyway, you can use the calculator, just straight away use calculator. So 2, 3 minus 8 minus 12. Okay, you have 3 values, minus 2, 2, and 1.5. But you see, obviously, I cannot just put everything. I cannot just put this comma to factor form and then put it inside the answer like that. I cannot do that. I must show some form of working. Okay, so first of all, how do I present the working? I got these answers in mind. Okay, this is my final point. This is my destination that I want to get. So I want to go back, I want to go back and solve for the factors. Okay, so from here, I see that minus 2 means what? 2 is a factor. So what I can do, I will do sub x equals to 2. So 2 times 8 plus 3 times 4 minus 8 minus 12 equals 0. Okay, so 16 plus 12 minus 16, 12. 2 square 4. Okay, so 16 plus 12 minus 8 minus 12. Is it? Let's check. 2, 3 minus 8, 12. 2 minus 2 and minus 1.5. So 2 cube 8, man. Alright, 16. So, okay, let's go back. 16 plus 12 minus 8 minus 12. I get 8. Oh, no. Sorry. My bad. Okay, it should be 8 times 2 lah. Okay, minus 12 equals 0. Yeah, this should make sense already. Okay, so if I divide my working proper, it will be 16 plus 12 minus 16 minus 12, which equals to 0. Therefore, x minus 2 is a factor. Yay, okay. So in a way, I guess and check my first value. To get my first linear factor. Okay, after that, how do I do it from there? The best way and the most fastest way is not long division, it's synthetic. So straight away, I do my synthetic division over here. Okay, so I will have my 2 over here. Then I get 2, 3, minus 8, 12. Okay, so from here, I want to go and find the quadratic result, the quadratic quotient. Okay, from dividing from x minus 2. Okay, so from here, 2, 4, 7, 14. Okay, this is a 6. Okay, and then 12, 0. What does this mean? This means that is actually equals to x minus 2 multiplied by 2x squared plus 7x plus 6. Because this 0 stands for remainder. That means there's no remainder. Okay, recently I went to do some research on this synthetic division. I realized that this is actually used in normal numbers as well. They actually can use the same way to replace long division. It's actually quite crazy, but then I see why they don't teach it in mainstream schools. Okay, next time got a chance, I share with you guys. is actually coming from an Indian mathematics way. It's called Vedic math. There is a proper way that to do synthetic division for normal whole numbers. It's quite crazy, but it's quite interesting. Okay. So now I need to go and factorize 2x squared plus 7x plus 6. And then from here, I will be able to know, or in the way able to factorize out from here is actually 2x. Okay, so it's 1.5 ma, so it's 2x plus 3, and then x plus 2. Like that. Factorize. So therefore, this is my factorized form. Factorize equals to like that. So this is a factorized form. Okay, so hence solve the equation x cubed minus over 4 plus 3 over 4x squared minus 4x minus 12 equals 0. Okay, very interesting over here. Now you got fractions. How now got fractions already. But still, we need, because since the word this is the word hence, I need to go and compare with what I have in front. So let's bring down what I have in front first. So 2x cubed plus 3x squared minus 8x minus 12 equals 0. Okay, and also from here, we also had the factorized form, which is x minus 2, 2x minus 3, x plus 2 equals 0. Because that is what I got from the factorized part from my previous part. So let's bring it down here first. And now we compare. How? Okay, so how do we compare? We compare it term by term in terms of the coefficients. One, we have 2. Then you got 1/4. Then you got 3. You got 3/4. Then you got 4. Then you got 8. Then it becomes 4. Then the 12 stays the same. That means there is something that changed in terms of the x values. Do you see that? You see that? Okay. So how do we ensure? How do we check that this? How do we go and do the comparison? Okay. From here, it could be a 2/4. It could be because from 2 become 1/4. So it's divided by 8. Then you divide by 4. Do you see that? Divide by 8, divide by 4, divide by 2. Then the 12 stays the same. So the thing is that we must be able to strike a comparison between this one and this one. How do we do so? Okay, let's check. Because now you see this new value of x takes a new value. That means if I were to substitute x as something in this new equation, I will be able to get the equation that I have at first in the first part. But now the thing is, what is it? What is it? Okay, so from here, the most straightforward way, right, is to see the x term. Because it changes for one x, it must change the same way for every other x. So as you can see, from minus 4x, it becomes 8x. Okay, say this is the first part. From the part 1 to part 2 is from minus 8x to minus 4x. What happened? That means at part 1, the value of x is being used. But in the part 2 over here, what happened? Half x is being used. Can see it? Half x is being used. Let you all have an idea of what's going on first. That means in the first, if part 1 equation, if I were to replace my x with half x, it will give me this equation I have in part 2. Because I need to think, how do I change the value of x in order to convert a minus 8x to a minus 4x? That is my key question. So the only way to do so is to change the x, take it away, and put a minus half x inside. Oh, sorry, not half, minus half x. Put a half x inside. So it will become 4x. And you will see that it actually stays the same for everything else. Okay, so how do we present it in this? How do we present in this equation? Okay, watch. So I have this idea in mind. Let's write it down here. It means what? 2 to the power of half x cubed plus 3 times half x squared minus 8 times half x minus 12 equals 0. This is what I'm looking for. You see, if I were to evaluate this, what do I get? I get 2 over 8x cubed plus 3 over 4x squared minus 4x minus 12 equals 0. And then this one is just nice 1/4. Isn't this what we are looking for here in this part? That means what? X is officially being replaced by a half x. X is replaced by half x. Let's have this conclusion. X is replaced with half x. We need to arrive at this conclusion and we must agree to this first before we can understand and move on. Okay? So, very important. How does this help us to solve the equation then? Okay? What does this mean? In our first part here, this is our factorized form. So that means all we need to do in this second equation is not to do the factorization all over again, but is to replace all the x values here to be half x. So how will we arrive? It will become like this. Half x minus 2, 2 times half x minus 3, and then half x plus 2 equals 0. This will be my new factorized format for the equation that I'm going to solve. Okay, so let's open it up and have a look. So 2 times half x becomes x minus 3. Then got half x plus 2 equals 0. So from here, we solve from here. Okay, so that means half x minus 2 equals 0. Half x equals to 2x equals to how many? 4. Okay, x minus 3 equals to 0, x equals to 3. And half x plus 2 equals 0, half x equals to minus 2, x equals to minus 4. So these are going to my new solutions. X equals to minus 4, x equals to 3, and x equals to 4. These are my new solutions to this part. Okay? Very important. If you were to go and do your factorization all over again, as if the first part never existed, you will get 0. FYI, I say first, you will get 0. Because they already use the word hence. If they use the word hence, right, that means you must use the things and the information that you get from the previous parts. If you just ignore and just do, if they are nice enough, they'll give you 1 mark for getting the correct answer. But all the meta marks in the middle will be gone. So please do not do that. Go and compare. Go and compare. The best way to compare, right, like I said, is to look at the x term. How did it convert from a minus 8x to x? Minus 8x to minus 4x. That means the x has been replaced with a half x. And then you use that to test it with the other terms, the x squared term, the x cubed term. Then you realize it will be correct. Okay, so this is the key statement. For you to see the illustration from the first part. From the first part where the equation is given, you take away x, you put in half x, and then you will get this new equation. Okay, of course, can you go and check with a calculator whether you get the correct answer? Of course, no problem. Just press 1/4, 1/4, then 3/4, minus 4, minus 12. Yes, you get the answer. Minus 4, 4, and minus 3. Oh, wait. 12, 12, minus 4, 3. 2x plus 3. Oh, my sign is wrong. Correct or not? Correct, 2 minus 4. This is the reason why you can use calculator and check, right? Okay. Equation, quadratic 2, 7, 6. Oh, these two are plus. But it's okay. The good thing is I can just immediately go and change back here. Okay, go and check it here. And 3 a plus. Okay, from here it's still a plus, and then this is a minus, this is a plus. Okay, small issues. You see, even if I can check, I can rectify it quickly. That is the best part, because it's not just about calculating, we must know how to check as well. So yes, 4 minus 4 and minus 3. That should be a correct answer. Yeah. Oh, we almost got our marks missed out there. But yes, now we got it. Okay. So these will be the answers. Okay, let's continue. 6:40 already. 1.5 hours. Okay, I need more time on explaining also. Write down and simplify the first 3 terms in the expansion in descending powers of x. Of 1 minus 2 over x to the power of 8. Descending powers of x. Okay, this one. Very, very, very tricky. Okay, and they almost trick us there as well, because it already said in descending powers of x. When they say descending powers of x, remember when I explained about binomial theorem, the powers, how does it relate? Whether it go up or go down, whether is it ascending or descending. Always remember, what is in front will descend. What's at the back will ascend. Okay? So for this one, right, if they say in descending powers of x, what I need to do is to actually switch the terms. To switch the terms. In descending powers of x. Because the question now is whether or not to switch the terms. But now we can see that the x is at the denominator position. So that means I will be expecting things like 2 over x, then 2 over x squared, then 2 over x cubed, 2 over x. Descending powers of x. Wordplay. Descending powers of x. I will want to switch the terms though. Because I want something to be 2 over something over x over 8, then x over 7, x over 6, because it is descending powers of x. That is what I want to get. That means I need to switch my terms. Yes, switch my terms. Wow, very tricky, because I need to do the extra level of thinking. Okay, so what I need to do is I will immediately switch the terms first when writing. Okay, so from here, write down the first 3 terms. If I were to write down my first 3 terms, how will it look like? It will look like this. Okay, number 1, I got my first term, power 8, confirm. Then 8 choose 1, write down the term, x to the power 7, then 1. Okay, in a way, the y at the back I can ignore because it's 1 to the power of 7, 1 to the power of 1, 1 square, 1 cube, 1, 1, 1, 1, 1. I don't really care. So I'll just leave it as alone. I just put 1. Okay, then 8 choose 2, minus 2 over x, power 6 times 1. Then plus. Okay, quite straightforward for this. So minus 2 to the power 8, straightforward. Okay, minus 2 to the power. Okay, very important here. What are they looking for? Do we put in the bracket or do we not put in the bracket? Okay, a lot of people will get confused here. The answer is yes, to put in the bracket. We have to put in the bracket. Then you must be asking me why. Because the minus is being embedded in the bracket. So we need to do this. So the answer will be 256. So a lot of people right now will be thinking, is it minus 2? It's like the minus is minus bracket 2 power 8 or minus 2 bracket power 8. The second one is minus 2 to the power of 8. Like that. Important. Don't get mixed up. Okay? Can. Continue. So same thing, minus 2 to the power of 7 is negative 128. So negative 128 times 8, because 8 choose 1. So I will just leave it as minus 1024 to the power of x to the power of 7. Okay, and 8 choose 2 is 28. So it's 28 times 2 power of 6. 2 power of 6 is 64 times 64. So it'll be 1792 over x to the power of 6 plus . First 3 terms in descending powers of x. Yes, correct. Because I want descending powers of x. I don't care the powers is. I don't care where the x is. I want descending powers of x. So as long as I need to check, ensure this is correct. This one and this one. Okay. Common mistake. People didn't switch the terms. So they just blindly just expand the first three terms. Then they'll get 1. Then they'll get something else, something else, something else, something else. Wrong. Because you'll get a constant, then x squared. That is ascending powers of x. Remember, I said that in the binomial theorem, the one at the back the powers will go up. The one at the front, the powers will go down. Just remember this one. Just remember this symbol. That's all. Okay, can. So I need to switch the terms. Okay, let's continue. Given that there is no x term in the expansion of blah 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 1 minus 2x minus kx squared times this one, find a constant term in expansion. Okay, interesting. So when they say no x term means what? No x term means what? Means 0x. Very important. That means the coefficient for the x term is 0. Find the constant term in the expansion means what? Constant. That means no x. This is no x. No x term and constant term are different things, guys. It's different things. Okay, a lot of people put them together and say it's the same thing. No, it's not. Okay, no x term means 0x. Constant term means no x. One is no coefficient, one is no x. Must differentiate, must get the difference. Okay, now with that in mind, let's start on this question. We got 1 minus 2x minus kx squared. And then I want to bring in the 3 terms that I got in front already, because that will potentially help me to solve over here. So immediately I want to write down my things already. So 256 over x8. Okay, minus 1024 over x7 plus 1792 over x6 plus Okay. Now, whether or not this will help me, I leave it here first. Anyway, this is what I already have. Okay, so I just leave it equals to that. Okay, now they say 0x term, then it's like, wow, one is like full of like, terms and stuff. Then one is like that. How to match? Okay, let me think first. 0x term, 0x. Are they really going to help me to find an x term? Ascending powers of x, descending powers of x. Because in order to have a 0x, I need to match terms from my 1 minus 2x minus kx squared and my binomial to give me a x term. And then the coefficient that I get, right, be 0. Okay, but now the question is, it seems that I need my ascending powers of x in my binomial. Right? I need my ascending powers, right? But the question in front says descending powers of x. Interesting, Okay. Nevertheless, because what I see from here, the observation is that because I got kx squared and x, that means I need to have a denominator of x and x squared in my binomial in order for me to match them together and to see something. But right now, I only got x8, x7, x6. I might make a mistake here. Descending powers of x, because it's x to the power minus 8, x to the power minus 7, x to the power minus 6. This is ascending. So that means I don't need to switch my terms. Alamak. Okay, but it's okay. That means what I need to do is I need to restart my part A. Okay. So this is also a way to check my answer as well. Is that I use my other part to check my answers for the previous part. Okay. It's impossible because over the past years of experience, it is impossible for them to ask you to go and expand again if they ask you to match stuff. That means if they are seeing that you need to expand again, right? That means something wrong with the first part already. Okay. Lesson learned. Okay. So let's remove this one. Let's remove this one as well. Okay. But anyway, since we already got the methods, let's go ahead and just do it as it is. Okay. It should be very easy for you guys. So if we 1 to the power 8 plus 8 choose 1, 1 to the power 7, then minus 2 over x plus 8 choose 2 times 1 to the power 6 minus 2 over x square plus okay, so it's 1 plus minus 16 over x. Okay, 8 choose 2 is how many? Just now 8 choose 2 is 15, I remember. Okay, so 8 choose 2, 28. Okay, 28 times 4. 112. So plus 112 over x square plus Okay, so let me just clean up the signs over here. 1 minus 16x 1 over 112 over x squared. Like that. Yeah, this should be it. Okay, now bringing this one down here. Okay, that should be something I can compare already. How? So now they say that given there's no x term. No x term. Okay, so we need to understand how do we get the x term in the first place. How do we get x term in the first place? X term. Okay, so how do we get the x term? There are a couple of ways we can do it. Number one, okay, I want to find the x term. So write down x term. Number one, I can match my 1 over here with nothing. Okay, no, so I cannot use this one. But I can do my minus 2x with 1 over here. So minus 2x times 1. What else? I also can match my minus kx squared with minus 16 over x. This allows me to get my second x term. Okay, so this comes with a bit of about pair and match to see what kind of powers do you get. So I'll get plus minus kx squared times minus 16 over x. Like that. Okay, let's see what else can we get to help me get my x term. If I will compare it this way, I will not get anything else already. X term, no more. That's all. Okay, so let's simplify this. So minus 2x, then this will be plus 16kx because this one and this one gets cancelled. So this tells me that the coefficient is 0. So what does it tell me? 16k minus 2 equals to 0. 16k equals to 2. K is 1 over 8. Okay, when k is 1 over 8, means what? I can put this k equals 1 over 8 into the expression over here and to find my constant term. Okay, so I'll put it back here. 2x minus 1 over 8 x squared multiplied by 1 minus 16 over x plus 112 over x squared. So now they say they want a what do you want? What do they want? They want a constant, the constant term in the expression. So constant term means what? No x. That means the x strike off already. You are left with a number. So you need to see how do I get the number. So what's the constant term? I have a let's do the matching again. 1 and 1. 1 times 1. You see, as retarded as it is, I will still put in the 1 times 1. Okay, to ensure clarity. What else I have? Minus 2 and minus 16 over x. So plus minus 2x multiplied by minus 16 over x. Okay, what do I have? Last one, which is the third one. Okay, no. Okay, I have my minus 1 over x squared and 112 over x squared. So I'll put in like that, minus 1 over x squared multiplied by my 112. Like that. Okay, this will allow me to get my constant term. So even though you see it's only 3 terms and matching, I want to write everything out in one line, then I go and slowly evaluate. That is my plan. Okay, 1 plus 32, my x and x get cancelled. What else? I have minus 112 divided by 8. 112 divided by 8 it will be 14 because my x squared gets cancelled. 14. Okay, so it will be 33 minus 14. 17. 1 plus 32 minus 14. 19. Whoops. 33 minus 19. Correct. So my constant term is 19. Okay? Can. Let's go through one last question before we end off today. Quite a lot of things going on, but nevertheless, I feel that it's a good practice. Good practice. Oh. The equation of a curve is y equals to 2 minus x minus 2x plus 3 divided by x minus 3. Find dy dx and d square y dx square. Why my last question is like that? Okay, but cool. I think it's still quite straightforward, even though there's quite a lot of steps to be done. But I think it's still quite manageable. So let's look at it one by one. Okay. So first of all, let's find dy dx. Dy dx, the 2 no more. Okay, then the x becomes minus 1. Now I need to differentiate 2 plus 3 over x minus 3. Okay, quite a lot of things over here. But the best way I feel is to make it a quotient, and to not make a quotient, make the quotient become a power of minus 1. Then I do product rule. At this point of time, a lot of people will be asking, oh, this one easy, quotient rule. Can quotient rule but personally I don't really like quotient rule. I like to do it product rule, then I go and switch it back. That is easier for me. Like I said, whichever method works, okay, up to you. This one I no particular best way to do it, okay, but I remember the product rule better, so I want to stick to product rule. Okay, so before I do the product rule, I will need to change this to 2x plus 3x minus 3 to the power of negative 1. Okay, so from there I can go and do my calculations from there. So minus stays the same. I bracket first just in case. Okay, so how do I do my product rule? I keep one, I differentiate the other, then I keep the other one, differentiate what I have in front, which is 2. Okay, 2, just 2. Okay, so it's time for me to clean up this part because I know that everything will be x minus 3 squared. So this is a minus 3 minus 2x, then multiplied by 2 times minus 3. Okay, so this allows me to get my, okay, I want to simplify what's inside first. So I'll get 2x plus 3. So the 2x kind of get cancelled out. The minus 6, so it's minus 3 minus 6. So I get minus 9 over x minus 3 squared. Then I put them together, I'll get minus 1 plus 9 over x minus 3 whole thing squared. Okay, so this is my dy dx. So from here, I want to find d square y dx square. D square y dx square is just I need to do this thing again. Okay, again. Dx y dx square. The minus 1 no more. Okay, now I just need to do a differentiation for 9 over x minus 3 the whole thing squared. Okay, so what will it become? Minus 2 over x minus 3 cubed. That's all. So this is my dxy, this is my d square y dx square, and this is my dy dx. Okay, let's move on. Find the x-coordinate of the stationary point of the curve. When they talk about stationary point straight away, it means what? Dy dx equals 0. So you just need to equate the dy dx to 0. Don't need to think so much. So minus 1 plus 9 over x minus 3 square equals 0. So 9 over x minus 3 square equals to 1. X minus 3, the whole thing square equals to 9. X minus 3 equals to plus minus 3. So x minus 3 equals to 3, or x minus 3 equals to minus 3. So x equals to 0, or x equals to 6. Okay? Just like that. Stationary point. I don't care if the stationary point is the maximum or the minimum. I don't care. Because now they're asking for the stationary point of the curve. So that's all. Quite straightforward. 3 marks. Determine the nature of each stationary point. That means when x is 6, when x is 0, whether the d square y dx square is positive or negative. Okay, that is where we need to look at the nature of each stationary point. Okay, so for this one, quite straightforward. So let's bring down the d square y dx square first. Will be equals to what? Minus 2 over x minus 3 cubed. This is my d square y dx square. So when I put in the value here, okay, what do I mean? So when x is 6, okay, my d square y dx square will be how many? Okay, so we quickly find it. So it's 6 minus 3. 6 minus 3, 3. 3 cubed. 3 cubed is 27. And we can see from here is obviously less than 0. If it's less than 0, how? Maximum point. Okay? Oh, 7 o'clock already. Okay. Yeah. Okay, so if the second derivative means what? If d square y dx square is less than 0, that means it's a maximum point. That means at that point, it's supposed to be set face. Set face. Okay, so same thing. Last one, where we want to sub in x equals to 0. So my d square y dx square is equals to what? Minus 2 over minus 3 cubed. It's going to be a negative. So this one is going to be a positive number because it's a minus 2 over minus 27. It's going to be so this is going to be a positive number. I don't care what number is. It's just going to be positive. If it's positive, it means what? Minimum point. Okay, so when x is 6, it's a maximum. When x is 0, it's a minimum. But of course, we also need to add in the context, means what? Local maxima. That means it's only at this point. Would the curve changes again? Because the curve is like that, like that. So it's only at that point is maximum or minimum. So I want to find a local maxima and a local minimum. Ta-da! Okay? Okay. Let's move on. Are there other parts? Okay, this is question 9 already. Question 9, or maybe go through next week. Okay? So this time is about 2 hours. Save to files. Please allow me to save. Yes. Hey, can save. But I don't know why the paper so big. 100 plus MB. But it's okay. So with that, we come to the end of the quickfire today. Okay, we just went through some very basic, more straightforward AMAX questions. Anyway, this is only a paper 1. Paper 1 is meant to be more straightforward as compared to paper 2. And then most likely there will be more difficult things like integration with curves. There will be more difficult things like the kinematics. All these things will be into paper 2 itself already. So let's see if we are able to complete this paper by the end of June holidays. During the June holidays, I will also be continuing the quickfire as well. There won't be any changes, so everything will just go on as per normal. So do continue to stay tuned to my quickfire sessions, and of course, this is not just meant to be a practice paper drilling session. Okay, if y'all got any questions, y'all got any topics or specific topics that you want me to go through with you, feel free to let me know, feel free to sound off so that I can just straight away go to the specific topics that you want to do. That will be better, because I've always feel that it's always better to do a mutual communication, because when y'all come in with certain questions, y'all will naturally pay more attention to do and to listen. Okay, as compared to me preparing a whole set of topics, you come in and just for the sake of it, then might as well I don't do. So with that, we will come to the end of this quick fire, and then we will see you guys in the next, either the next week or next 2 weeks. Because last week I said whether or not to do it this week, man. Okay, so this most likely I'll continue. That means every week I'll still do the same thing. But anyway, because I have already papers being lined up already. Okay, and also maybe what I will be doing is at July, that means at end of the holidays. Okay, I will actually take this quick fire opportunity, right, to go through the mock papers that I have gone through with the students during the exam training sessions, so that I feel that the majority can also benefit lah. Okay, so of course, like I said, if you all want to sign up for the program, do let me know. There are still slots available, so you all can actually simulate the exam environment to sit down and do the paper. Okay, I say again, what are the subjects that is being available for this program? Number one, P6 Maths, P6 Science, Sec 4 E-Maths Paper 1, Paper 2, A-Maths Paper 1, Paper 2. Paper 1 and Paper 2 for E-Maths and A-Maths are on separate days. So at least one day I can focus on one paper lah. You know, it's quite shack, you know. Like today we spent like 1.5 hours doing like 9 questions, but it's only on paper 1. Okay, so paper 1 and paper 2 will be on separate days. And then of course, if you guys want to sign up for multiple sessions, there will be 10% off discount lah. So it's to encourage you guys to actually come for more sessions, and at the same time to, you know, to bring your friends as well. If you want to bring your friends and come along together and have a like a mini competition, yes, go ahead, by all means, the more the merrier. Okay, so hopefully to see you guys in the exam training program, and I will see you guys next week for the